All right, get ready for a deep dive.
A deep dive into geometry.
Yeah, we're going to be looking at lines and angles.
That's right.
It's like the foundation of, like, everything,
Yeah.
Like, if you want to understand how anything is built or designed,
Yeah, like the blueprint.
it's like the secret code.
Exact.
And we've got this chapter here, lines and angles, ready to break it all down.
We're ready. We've got.
But before we get, like, lost in the weeds a bit,
Yeah.
what's one of the things that you think is just, like, the coolest thing about this stuff?
Well, for me, it's amazing to think that just starting with lines and angles, those really simple building blocks,
Right.
you can describe and understand something as complex as like a skyscraper.
Oh, that's a great example.
Yeah, it's all just lines and angles just put together in a really precise way.
Right, and they have to be put together in a precise way.
Yeah,
Because if they're not, then the thing's going to fall down.
exactly. It all comes down to geometry.
So let's go back to the beginning a little bit.
Yeah.
Let's do it. The chapter starts with, definitions of lines and line segments and rays. It's kind of like Geometry 101.
Yeah, back to basics.
But I think it's important to revisit those basics.
Absolutely, yeah, because, they can be easy to overlook, but even those basic concepts have, like, hidden depths to them.
Totally. Like, I was thinking about rays, right?
Okay.
Which is just, a line that goes on forever in one direction.
Yeah.
It's like kind of poetic in a way.
Yeah,
Like this simple thing representing infinity.
absolutely. And those infinite lines and rays can then come together to form something finite and measurable, like an angle.
Exactly.
Yeah.
And we've got all these different types of angles, right? We've got acute angles, which are those little cute ones,
Yeah.
and obtuse angles, which are the bigger ones,
Right.
and even those reflex angles, which are like bigger than 180 degrees.
Those are the ones that go all the way around.
Oops, you're like, whoa, I never thought about angles that big.
Yeah, and they're everywhere, right? Think about a car steering wheel. You can turn it all the way around.
That's true. I never even thought of that.
That's a reflex angle.
So those are some of the basics, right?
Yeah.
We've got lines, we've got rays, we've got angles. And, the chapter reminds us about complementary and supplementary angles.
Yeah, right. Yeah.
Those pairs that add up to 90 degrees or 180 degrees.
Those are good to remember.
But things start to get really interesting, I think, when we start talking about intersecting lines.
That's where the fun begins.
Because that's where we start to see all these relationships between different angles.
All the patterns start to emerge.
We've got vertically opposite angles,
Yep.
adjacent angles,
Mhm.
linear pairs. It's like a whole new world opens up.
Exactly. And it's all connected, right?
And it's all connected,
Yeah.
yeah. So, for example, let's talk about those vertically opposite angles for a second.
Okay. Yeah.
So if you have two lines that intersect,
Yeah.
right, the angles that are opposite each other,
Right.
those are always equal.
Always. It's like looking in a mirror, they're identical.
Yeah. And that's not just a cool, like, geometric fact.
Right.
That actually has real-world implications, like for engineers building bridges.
Exactly. Yeah. Those angles have to be equal for the bridge to be stable.
So it's like all this stuff is, like, really important for, making sure that the world around us works properly.
It's all connected. Geometry is the foundation of so much in our world.
It's like geometry is holding everything together behind the scenes.
It really is. And those angle relationships we were just talking about, they're key to understanding other geometric concepts too.
Oh, totally. Like, what about those linear pairs? Those are pretty cool.
Linear pairs, yeah. Always a good time with those.
So they're like two angles that sit side by side on a straight line.
Right, adjacent angles. And their measures always add up to 180 degrees.
Like always, always.
Always. That's where the linear pair axiom comes in.
Right, the axiom. It's
Yeah.
like the rule that makes it official.
Exactly. It basically states that if you have two angles forming a straight line, those angles got to add up to 180 degrees.
No two ways about it.
Yeah.
And the chapter even walks us through the proof for this,
Yeah, it breaks down why it has to be true, logically.
which is cool because it's not just like some random rule.
Well, right. It's all connected back to those fundamental properties of angles.
And speaking of proofs, the chapter also proves that those vertically opposite angles are always equal.
Oh, yeah, that's a good one.
So we're talking about the angles that are like directly across from each other when two lines cross.
Right, like the opposite corners of an X.
They're always the same no matter what.
Exactly. No matter how the lines intersect, those opposite angles will always have the same measure.
That's wild. It's like there's this hidden symmetry in everything.
And geometry helps us see that symmetry and understand why it exists.
Okay, but before we get too far ahead of ourselves,
Yeah.
we got to talk about parallel lines.
Ah, yes. Parallel lines cut by a transversal.
That's a whole other can of worms.
It's like opening up a kaleidoscope of angles. You've got so many different pairs and relationships to explore.
Okay, so you've got corresponding angles, alternate interior angles, alternate exterior angles.
Yeah.
It can be tough to keep them all straight.
It definitely helps to visualize it, right?
Totally. Like, I always picture those parallel lines as rows in a notebook, and the transversal is like a line cutting across them.
I like that. And then those corresponding angles, they're like in the same position at each intersection.
So if the top left angle is, say, 30 degrees, the bottom right angle would also be 30 degrees.
Exactly. Same position relative to the transversal and the parallel lines means they've got to have the same measure.
Okay, that makes sense. And then we have those alternate interior angles, right?
Yep, those are the ones that are on opposite sides of the transversal, but inside the parallel lines.
And they're equal too, right, if we're talking about parallel lines.
You got it. Equal angles all over the place when you've got parallel lines in the mix.
Yes, blowing my mind. And what about those angles that are on the same side of the transversal, but inside the parallel lines?
Ah, those are the interior angles on the same side of the transversal.
Right, right. They're not equal, though, are they?
Nope, those ones are supplementary.
Meaning they add up to 180 degrees.
Precisely.
Wow. It's like every combination of angles has a special relationship when you're dealing with parallel lines.
It's all connected. And it's not just random. It all comes back to those basic properties of angles and lines.
So cool. And then the chapter talks about lines parallel to the same line.
Right, the transitive property.
It's like if line A is parallel to line B and line B is parallel to line C, then A and C are also parallel, right?
That's right. It's like a chain reaction of parallelism.
Geometry is full of surprises. But speaking of cool connections,
Yeah.
don't all these parallel lines eventually lead us back to triangles?
They sure do. Triangles are all about those angles, and those parallel lines help us unlock some of their biggest secrets.
Like the angle sum property.
Exactly. Get ready for some triangle magic because things are about to get really interesting.
Triangles, triangles, triangles. They're like the rock stars of geometry.
They really are. Simple shapes, but they hold so much power.
So what is it about triangles? What's their claim to fame in the geometry world?
Well, it all starts with the angle sum property.
Okay, the angle sum property.
This is a big one. It states that the angles inside any triangle, no matter what,
Yeah.
they'll always add up to 180 degrees.
Always. Like no exceptions.
No exceptions. It's like a universal truth in geometry.
That's pretty wild. So it doesn't matter if the triangle's like super pointy or really flat.
Nope, doesn't matter at all. Squished, stretched, upside down, those angles will always add up to 180 degrees.
Okay, but how do we know that for sure? Like, is there a way to prove it?
There is. And guess what? It uses our knowledge of parallel lines.
Oh, really?
Yeah. If you draw a line parallel to one side of the triangle
Okay.
and you make it go through the opposite vertex, suddenly you've got those corresponding angles and alternate interior angles.
It's like we're using parallel lines to crack the code of triangles.
Exactly.
Yeah.
And because we know those angle relationships are always true for parallel lines.
We can use them to prove the angle sum property for triangle.
Precisely. It's all connected.
My mind is blown.
Hmm.
So this angle sum property, it's not just some abstract idea.
Right.
It actually matters in the real world. Right.
Absolutely. Think about architects designing a roof, for example.
Okay.
They need to understand those angle relationships to make sure the roof is stable and strong.
It's like geometry is the secret ingredient in good architecture.
It's true. And don't even get me started on surveyors.
Oh, yeah, they use triangles all the time.
They use those angle properties to measure distances and create accurate maps.
Triangles are like the unsung heroes of the mapping world.
Totally.
Mhm.
But we can't forget about exterior angles.
Oh, right. The angles that hang out outside the triangle.
Those guys are important too. They have a special relationship with the interior angles.
Okay, I'm listening. Tell me now.
So remember how we extended one side of the triangle earlier?
Yeah.
That created an exterior angle.
Yeah.
And that exterior angle, it's always equal to the sum of the two opposite interior angles.
Wait, hold on. Let me get this straight.
Yeah.
We're talking about the two angles inside the triangle that are farthest away from that exterior angle.
Exactly. It's like those two interior angles are sending their power out to that exterior angle.
And it always adds up perfectly. That's wild.
Always. It's a fundamental property of triangles.
Okay, you've got to give me an example of where this matters in real life.
Think about navigation. Sailors and pilots, they use triangulation,
Okay.
which often involves measuring those exterior angles.
To figure out their position.
Exactly. It's like using triangles to navigate the world.
That's incredible. Triangles are way more powerful than I ever gave them credit for.
They're full of surprises, and we've only just scratched the surface here.
I know, right? Feels like we could talk about this stuff for hours.
There's always more to explore in the world of geometry, that's for sure.
Well, I've had a blast diving into lines, angles, and triangles with you today.
Me too. It's been a fun journey.
And for everyone listening, we hope you've learned a thing or two about these geometric wonders.
And maybe you'll even start seeing the world a little differently now, noticing all those hidden angles and relationships.
Because geometry isn't just in textbooks, it's everywhere. Thanks for joining us on this deep dive, and we'll see you next time.